In this video 5.4, we are going to be looking at point slope form. By the end of the video and work time in class, you should be able to say, I can write and graph linear functions using point slope form. I want to go back and just kind of review some key points from our previous lesson. What is slope-intercept form? We know that this is y equals mx plus b, where the m is the slope and the b is the y-intercept. What is the slope and the y-intercept of y equals 3x minus 2? The slope is 3. The y-intercept is negative 2. What is the slope and the y-intercept of y equals negative 1/2 x plus 4? The slope is negative 1/2. The y-intercept is 4. What is an equation of the line with the slope negative 3/4 and y-intercept 7? This would be y equals negative 3/4 x plus 7. I'm going to graph a line, and looking at this line here, we should be able to come up with an equation in the form of slope-intercept form. And that would be y equals 2x, because the slope is rise 2, run 1. And then that y-intercept is at 1, so plus 1. So y equals 2x plus 1. I'm going to make another graph here. Connect the points. And if we were going to write an equation for this one in slope-intercept form, we would go y equals, we see the slope is run 1, or rise 1, run 2, rise 1, run 2, rise 1, run 2. So it looks like positive 1/2 x. And then we look at the y-intercept, and we go, wait a minute, that y-intercept is not at a whole number, so we're not really quite sure exactly where that y-intercept is. So slope-intercept form is one form a linear function can take the place of. Another form that we're going to work with now is point slope form. We could take this line, find the equation of the line using point slope form. Point slope form, definition, it's the point slope form of an equation of a non-vertical, can't be vertical line, with slope m, and through point, it goes through a point, and this, ladies and gentlemen, is what the point slope form is. These should be shifted down a little bit, but right here is point slope form. Where you have a point that's on the graph, you have an x-coordinate and a y-coordinate in the function, and it's y minus y sub 1, that y-coordinate equals m's your slope, times in parentheses x minus x sub 1, which is the x-coordinate of the point that's on your line. So, if we look here, again, this is going to be the y-coordinate of one of your points. This right here is your slope. And this right here is an x-coordinate from the y-coordinate that you used in the y sub 1. So you need one point and the slope of the line to write the equation. In looking at this graph here, we know how to come up with a point. We just see at what point do we see a point land at whole numbers where the x-coordinate and the y-coordinate are whole numbers. For example, here, that point that I circled is at 2, 1. So I would use my 2 for the x sub 1 and the 1 for my y sub 1 in our form. In terms of finding the m, which is your slope, your rise over your run, you find another point go from one point to the other, see what's your rise, what's your run, to figure out the slope in your form. So a line that passes through 1, -4, and has a slope of 3, what is that equation in point slope form? So we know what that form is. The form is, whoopsies, as I'm dropping markers, that slope, or that form is y minus y sub 1 equals m times x minus x sub 1. We're going to replace values here, 1 for the x sub 1, and -4 for our y sub 1. Now it's y minus y sub 1. So this would end up being y minus -4, which we know ends up being plus 4, equals with a slope of 3 times x minus 1. So y plus 4 equals 3 times, in parentheses, x minus 1 is our linear equation in point slope form. Now if I went through and simplified this, I use the distributive property, I'd have y plus 4 equals 3x minus 3, and I subtract 4 from both sides, I'm left with y equals 3x minus 7. Notice that right here is slope-intercept form. So you can take point slope form and convert it to slope-intercept form by isolating the y and simplifying. What is the graph of the equation y plus 3 is the same as -2 times the quantity x minus 2? What you want to do is pick out where that point is. That point, since this would have to be minus, that point ends up being -2 is our x coordinate, or sorry about that, that'd be a 2, because it's minus x minus your y, or your x coordinate right here. So your x coordinate is 2, your y coordinate would be -3. Okay, our slope is at -2. So we start by taking the point 2, -3. Put your point right there at 2, -3. And then your slope is -2. So if you rise, run, it would be down 2, right 1. Down 2, right 1. Down 2, right 1. Or I could go up 2, left 1. Up 2, left 1. Up 2, left 1. Up 2, left 1. There's our -2 slope. So with one point and the slope, we can draw the linear function. What is the equation in point slope form of the line that's shown here? Remember, we need y minus y sub 1 equals m times, in parentheses, x minus x sub 1. So we need a point, and in this case you can pick either point. You can pick -2, 1 or 4, 4, and we need our slope, and our slope here is rise 2, run 4. Rise, oh, actually if we look at that, I highlighted both points, so we're going to go rise 3, run 6 from point to point, which would also reduce to rise 2, run 4, which also reduces to rise 1, run 2, because they all end up being the same, because if you rise 3 and you run 6, that reduces to 1/2, or which that 2/4 would reduce the same to 1/2. So we have our slope, and then we can pick either point. I guess we could write two answers. Y minus, now our y coordinate, 1, equals 1/2, which is your slope, times x minus your x coordinate, which is -2, so that would be +2. Or if you pick your other point, it'd be y minus 4, which is the y coordinate, equals the slope, times x minus the x coordinate. So either of these would be correct. This table here shows the amount of time Julio works and his total wages. So we can see here, if I move this up, it goes up by 5s, 5, 10, 15, 20. Okay, so I'm going to move this back down here. We're going to do a few things. First, what equation in slope-intercept form would give Julio's wages at any time? So now we're looking at slope-intercept form. Okay, and then what do the slope and the y-intercept represent? So what we would want to do here, if we're going to find the slope, we can find the slope, the m. We can do, let's just pick 2 points. So I'm going to pick these 2 points to find the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the slope would be 80 divided by 5. So the slope would give us 16. Okay. Now, the other thing we notice here is that these are constantly going up by 80. As we go up for 5, it goes up 80. If I go backwards and subtract 80, then at 0 hours of pay, or 0 hours of work, I should say, if we go backwards 5 hours, it's 0. 130 minus that 80 would give you 50. So that's basically saying here that Julio, he gets paid $50 plus 16 for every hour. So the slope here, the slope 16, that's your slope, that represents his hourly pay. And the 50, that's the y-intercept, is that fixed amount of income per pay period. It would be, that'd be per pay period. He gets a $50 plus for $16 so every hour he gets paid. So this is our equation, our linear function in slope-intercept form. Y equals 16x plus 50, or vice versa, where the 16 is the hourly pay and the 50 is the fixed amount of income every pay period. Can you say I can write and graph linear functions using point-slope form? Write a summary and reflection and be prepared for the work time in class.